First you start with single phase motors, then the single phase induction motor. Okay. Single phase motors मतलब सब बुझी बोधे এটা দরকার পড় না পারে না ওইটা আচ্ছা আচ্ছা ওকে ওকে because in my classroom আমার classroom র strength অছন্তি বর্তমান 85 so that too without speaker we have to tell हाँ स्पीकर बिना यूज करिक आम करूँ इनटेक 60 तापर ऐड हो जाती ना सेकेंड इयर लेटरल एंट्री तापर से AWS अन्य ब्रांच चेंज आम गोटे अच्छी 10% सीट ब्रांच चेंज हो आसवे देखिए ऑलमोस्ट 85 आम था स्ट्रेंथ इच क्लास रो so single phase motors have a similar construction to three phase motors any motor means stationary part and rotating part stator and rotors so because it is single phase means it will receive the single phase AC supply so AC winding that is placed on the stator and the short circuited conductors that are placed in the rotor okay stator and rotor the principle of operation is almost similar to our induction motors okay. Why it is used the single phase motors they need less maintenance than three phase motors and that's why they will last longer no this is true for small power okay for high power machine three phase is preferred for small power fractional kilowatt machines single phase is preferred say okay large industry jiva mane three phase induction motors are used say so single phase motors are used in equipment and machines that are smaller in size and requires less horsepower and such as some example the food use hochi pumps refrigerator fan compressors no and these are the machines these are the equipment where single phase machines are used okay and the classification tab start kariyo depending on the construction one is induction motor repulsion motor series motor and unexcited synchronous motor किंतु only induction motor is there in your syllabus so induction motor को हम start करिया okay so single phase induction motor so single phase induction motor is small size motor generally fractional kilowatt rating okay and they work on the principle of electromagnetic induction to create a rotating magnetic field एटा हम देखियो एटा किंतु rotating magnetic field टा किंतु प्रोड्यूस होची and where it is used same thing ja padthila eta what is the advantage the simplicity single phase induction motors are simple in construction compared to three phase motors and suitable for residential use cost effective and they are plentifully available kintu esabu applicable for small power rating only for large power gale just the opposite he jibo to so three phase motors are preferred say okay. So single phase motor consists of a single phase winding mounted on the stator and cage winding on the rotor okay three phase induction motor padthila three phase winding the stator winding receives three phase AC supply so here the stator winding will receive single phase AC supply single phase AC kono this is single phase is sinusoidally varying alternating quantity so sinusoidally varying voltage is applied across the stator and rotor is generally to reduce the cost it is of squirrel cage type okay squirrel cage type means it is connected by end rings at the both the ends okay squirrel cage rotor construction ja thila so when a single phase supply is connected to the stator winding a pulsating magnetic field is produced mean single what is the nature of single phase sinusoidally varying so the magnetic field that is produced by the single phase supply will be a pulsating one say so under these conditions the rotor does not rotate so some social arrangements are required to start this single phase motors say so it am the detail dekhiya so a single phase AC supply is split into two phases to be applied to the stator winding so again you recall the three phase induction motor it receives the three phase AC supply just I am padithile last class when three phase winding carries a three phase current then a rotating magnetic field is produced. तापर आमर इंडक्शन मोटर टा स्टार्ट होतला. So once the rotating magnetic field is produced, to begin with the rotor is at rest. No, so the field is rotating. So flux linking the rotor conductor is changing, and according to Faraday's law of electromagnetic induction, EMF will be induced in the rotor circuit. And rotor circuit is always closed one. No, so rotor circuit is closed one. Squirrel cage बने तो पूरा close ही end ring देगी हम close कर देती है. So EMF is induced. Now because it is closed one, the current will flow in the rotor circuit. Which direction? Now according to Lentz's law, current will flow in such a direction that it will oppose the cause producing it. So current flow Allah. In the current carrying conductor, if it is placed in a magnetic field, it will experience a force. So fundamental rule कितना कहे तो no. Current carrying conductor placed in a magnetic field. कौन current? Rotor is carrying current that is placed in this rotating magnetic field. So then it will experience a force. Which direction? Motor principle bar kar direction of field and the direction of current, the rotor will move in this direction. Which direction? That is governed by Lentz's law. So it will move in such a direction that it will oppose the cause producing it. Cause is the rotation of this magnetic field. So rotor will rotate in the same direction as that of the magnetic field, so that the relative speed between the flux and rotor will decrease. So this is the same principle ADB. Only problem here is the single phase supply cannot produce rotating magnetic field. Okay. Once the rotating magnetic field is produced, then like similar to our induction motor, it will start. The rotor will rotate. So a single phase supply cannot be. So other means हम देखिए what are the methods actually. But a two phase supply can produce a rotating magnetic field. It will देखिए derivation करिया. Okay. Then the same rotor principle. The flux links with the rotor conductor and cuts the conductors of the rotor. According to Faraday's law of electromagnetic induction, EMF gets induced in the rotor. Current begins to flow in the rotor after the rotor circuit is closed. Always it is closed. So a current carrying conductor in a magnetic field experiences a force known as the Lorentz force, creating a torque that causes the rotor to rotate. Similar to our induction motors. Okay. So these are the parts. Single phase supply is connected to the stationary stator winding. So there is a starting winding. So it requires one more winding, auxiliary winding. Okay. Why it requires? It will be okay. So there are two windings. One is starting winding, one is running winding or main winding. Good main, good starting purpose, good winding dakara. And these are the parts. Okay, small motors. So construction, even all the machines, the similar construction. Stationary part is known as the starter. So it will consist of frames and core and the winding. So winding is designed to receive the single phase supply. And যদি দুইটা বাইন্ডিং ইউজ করছে, there will be main binding and auxiliary binding. First we will see if single phase binding is there, how it will behave. Only one binding is there. Next, one more binding, auxiliary binding, why it is required, then if it is present, how to deal with this one. Okay. And rotor is squirrel cage design. এটা সব প্রিভিয়াস যা পড়ছিবে। So even though many advantage, main disadvantage is single phase motor is not self-starting. And constructionally, this is more or less similar to polyphase induction motor, except that its starter is provided with a single phase binding. Polyphase induction motor is three phase binding. And generally a centrifugal switch is used, not always. Centrifugal switch is used in some types of motors in order to cut out a binding used only for the starting purpose. It will be detailed bitaru jiva dekhiya. Okay. So starter binding on the stator, distributor starter binding, squirrel cage rotor. These are main parts. And when fed from a single phase supply, its starter binding produces a field which is only alternating. No, तुम AC voltage apply करछो, so AC current will flow. AC current is sinusoidally varying. So the field produced by the stator winding will be alternating in nature. So this will produce only a pulsating torque. An alternating or pulsating flux acting on a stationary squirrel cage rotor cannot produce the rotation. Okay, so RMF जो पढ़ते rotating magnetic field it produce हबो नहीं. That's why the single phase motor is not self starting. No, cause जो पढ़े why single phase motor is not self starting? Because single phase supply cannot produce a rotating magnetic field. That is the answer. Rotating magnetic produce हला माने same similar to induction motor सब चली चली जीव start हबो. It cannot produce a rotating magnetic field. How to do the analysis? However, if the rotor of such a machine is given an initial start in either direction, then immediately the torque rises and the motor accelerates to its final speed. A behavior में by using the double field revolving theory analysis करी परिया. What is this double field revolving theory? So this theory makes use of the idea that the alternating quantity can be represented by two oppositely rotating vectors of half magnitude. एटा ताप परटा देखियो बोल देखियो this one एटी के concept आसीबो. So AC supply is given to the stator. So a sinusoidally varying voltage is produced and sinusoidally varying current is produced. That is represented by a vector. Suppose this one, this F. So this is sinusoidally varying. No. How to represent the sine quantity? Sinusoidal quantity. Generally we use sine of this one, maximum value, and sine of this one. And if you compare the sine and cos, the waveforms are similar. Only sine is shifted by some angle. No, sine जदि तब देखियो 90 degree shift होची. Sine रो देखियो ये बड़ा figure out करिवा. This is the full cycle of sine. 8 रो पार्ट टा cos रो variation होची. ना cos रो variation जदि नबा this variation. So sine representation, any wave, if it is sinusoidally varying, that can be represented by using sine or cos also. Okay, because the shape will be same. Continuously हम जो देखिए shape will be same. So sometimes derivation रे easy होगा पे हमें sine भी नहीं जाओ, sometimes cos भी नहीं था उससे दा. नॉलेज है तो confuse हो. Sine वाले general था idea only sine, using sine quantity only you can represent maximum value and sine of that one. If it is shifted, cos is represent करते as if it is shifted by 90 degree. No. So a sinusoidally space distributed MMF is produced whose peak value pulsates with time. So MMF is proportional to cos theta will call it. And this is cos omega t. Theta जो quantity is, this is a sinusoidal varying quantity. Okay. So you can represent this by a maximum value and sin omega t, strictly speaking. Or you can represent the maximum value by cos omega t also. So both are same representation. Waveform will be same, sine wave or cos wave. Okay. So this is our f suppose. And at any point, what is the component of f? If this angle is theta, f cos theta. And this f is this one. So it is. So the MMF has both space and time distribution, and f is represented by f maximum cos theta into cos omega t. It is the f value टा एडा कर दो. So f value माने f maximum cos omega t into cos theta. So this is in the form of cos A into cos B, and this cos A and cos B can be represented by cos A into cos B, and cos A into cos B can be represented by half cos A minus B plus cos A plus B. आगु जब सिम्पल करिया बने, so half into f maximum cos theta minus omega t plus half f maximum cos theta plus omega t. Okay. तब again तब original का आसियो. So when you represent a sinusoidal quantity by a vector, so these two equations, okay, so it consists of two components. Okay, one is theta minus omega t, the second one is theta plus omega t. So this tells us that a pulsating single phase field can be considered as a superposition of two rotating fields rotating at synchronous speed in opposite direction. Our next figure ta dekhila how to clear hobo eta. So this is for theoretical analysis purpose. We are assuming as if the sinusoidal quantity can be represented by two field rotating in anti-clockwise direction like this one. A figure eta bhi nahi, it is dekhile it to goto kattili ta mu this one. Okay, so any sinusoidal quantity will be represented by the sinusoidal varying quantity. Suppose there are two vectors, okay, like this one. So when both the vectors, so these two vectors are rotating in opposite direction. So one is rotating in suppose clockwise direction, mane eta anti-clockwise direction rotate hochi. So at a particular instant, dekhiyo, both the vectors are in this position. So if both the vectors are in this position, what is the resultant? Resultant both are equal and opposite. So resultant will be 0. After some time, suppose किस समय पर ये एटी आसिला, A vector एटी आसिला. So both are in the same direction. So the resultant will be this maximum. Okay. So if हम complete डेटा करिया, कौन होगा तमरो? We will get a wave like this one. Okay. So when two vectors, if you take the two vectors and both are rotating in opposite direction, and what is the resultant at each instant of time जो हम बाहर करिया, we will get a sine curve. So in other words, sine curve can be represented by the two vectors rotating in the opposite direction. मुझे बहुत बड़ फिगर थिला, देखली ए फिगर रो बुझले टिके जणा पड़ुछ, क्लियर होछ. Anyway, जोड़ा कि तांगे बुझिए, पिला जेंत बुझिबे how a sinusoidal quantity can be represented by two vectors rotating in the opposite direction. This is one way of explaining this one. Okay. Jodi how kichhi suitable method achi, you can follow that one. Eta kon opposite re. You first you take two vectors. A to start kariyo. You take the two vectors. What is the resultant now? So in this position, the resultant is 0. A to draw color dot. Then after some point, both the vectors are occupying this position. So what is the resultant? This phi maximum. So this is the phi maximum value. After some time, तमे 8 आसियो 0 आसिबो. Other both are in this direction आसिबो. So negative maximum. So if you complete one cycle, we will get a sine wave. So two vectors, the resultant will vary in a sinusoidal manner. Or in other words, because it is varying in sinusoidal manner, we will assume that it consists of two vectors rotating in the opposite direction. So this is double field revolving theory. एटा explanation पाई. ता पूर्वर ए हिसाब रे भी देखि परियो field हिसाब रे. Okay. A field करगी बर्तन two vectors are rotating in the opposite direction. Okay. So out of these two vectors, one is known as the forward rotating field and second one is rotating in the backward rotating field. Well, single phase motor हम जो first start कले, it is not producing any rotating field. But data rotating field asilani. Hela. But one is rotating in the forward direction, one is rotating in the backward direction. Both are at the synchronous speed. Okay. So data field bane. Now there will be induced EMF due to forward field, induced EMF due to the backward field, rotor current due to forward field and rotor current due to backward field. Okay. And both these fields have an amplitude equal to half the maximum value. तापरे the forward and backward fields along with the rotor, which is rotating at speed n in the direction of forward field. तापरे हम जो स्लिप बाहर करिया like our suppose motor is now in operation condition, motor is running at a particular speed n, okay. So it बर्तमान दुईटा स्लीप पाइबा इंडक्शन मोटर रे हम गोटे स्लीप पाउथले व्हाट इज स्लीप द सिंक्रोनस स्पीड माइनस द एक्चुअल स्पीड बाय सिंक्रोनस स्पीड हैला इट बर्तमान दुईटा सिंक्रोनस स्पीड ऑफ फील्ड रो सिंक्रोनस स्पीड माने स्पीड ऑफ द रोटेटिंग मैग्नेटिक फील्ड हियर वन फील्ड इज रोटेटिंग एट फॉरवर्ड सेम डायरेक्शन the other field is rotating in the opposite direction, so we will get the two slips here, the forward slip and backward slip. So SF जो नवा forward slip जिंदु हम बाहर करतले ns minus n by ns is equal to s will बाहर करतले, and with respect to the backward field, so n तक minus n नवा में, okay, with respect to this one, this is rotating in the opposite direction, so देखिए ये आसियो 2 minus s, so the two slips will be s and 2 minus s. At starting the slip rotor is at rest, no, so at starting n is equal to 0, so sf will be equal to ns by ns 1 and sb is equal to n 1 hala 2 minus 1 is equal to 1, so both starting forward slip and backward slip value is equal to 1. During running condition so the slip amar habo, and generally the slip is very less, no, induction motor jo torque slip characteristics dekhibo or speed slip characteristics, so slip is around 2 to 5%, so range re your asibo slip tomra. It would on one more figure, no, you can take any you have to concept naka it would odd lauchi for a student it will look odd, no. Pulsating field, how it can be represented by two rotating magnetic field, सेटा clear करे पड़ियो first तंको, so either you use this method or से जा को तो सेटा करो, or you can take the two field, okay, ए जो two field मुझे नहीं थी, okay, सिम करी करियो, तापर कौन थला ए टू हम देखो जो एटा कौन जे हाँ. So under the stationary rotor condition, at the starting corner, the rotor speed is 0. So S is equal to 1. So two rotating field slip past the rotor at the same slip, S is equal to 1. Forward, backward same ala. Equal current in the squirrel cage rotor. So these two rotating field have the same strength and produce equal and opposite torques, resulting in net starting torque of 0 value. And that's why the single phase motor are not self-starting. आउट क्वेश्चन तुम आसे जनरल भाई बारे की कुछ पचारि सिंगल फेज इंडक्शन मोटर ओनली स्टार्टर वाइंडिंग अछि ऑक्सिलरी वाइंडिंग नाही त टॉर्क प्रोड्यूस होउछ ना नाही एट स्टार्टिंग टॉर्क प्रोड्यूस होउछि किंतु नेट टॉर्क इज 0 विल कहबो हला बिकॉज़ फॉर ड्यू टू द फॉरवर्ड फील्ड द टॉर्क इज प्रोड्यूस्ड फॉर अ बैकवर्ड फील्ड वन मोर टॉर्क इज प्रोड्यूस्ड बोथ आर इक्वल एंड ऑपोजिट. So net torque is 0, but torque is not 0. Okay. And net torque exist कले तमर starting torque टा काम करी start हबो motor टा. Okay. It is not self starting. Okay. तापर in second रे पड़ियो. Suppose if however the rotor is made to run at a speed n in the direction of any field, say forward field, माने by hand की कौन जदि हमें बढ़ेगा फर्स्ट स्लिप टा एट स्टार्टिंग s इज इक्वल टू 0 थिला 1 थिला ना स्टार्टिंग रे s इज इक्वल टू 1 बोथ फॉरवर्ड स्लिप एंड बैकवर्ड स्लिप जेतो गोटे फॉरवर्ड डायरेक्शन हम रोटेट कर देले रोटेट करले s रो वैल्यू टा कोन हबो 1 रो कमिबो हला सेटा होछि इफ द रोटर इज मेड टू रन एट and in the direction of the forward field the two slips are now s and 2 minus s. The slip interaction kono the backward field experience a high slip and forward slip will be very low. मुझे कोई दिली the generally during running condition the value of slip is very less 2 to 5%. Suppose 0.002 नवा माने s is equal to 0.005 and backward slip will be 1.95 कौन ए value आसियो गोटे बोला high value and low value. So the rotor current magnitude in the power factor ए सब तमरो चेंज हो द बैकवर्ड फील्ड इंड्यूसेस सिग्निफिकेंटली लार्ज करंट इन द रोटर कंपेयर टू द स्टैंड स्टिल कंडीशन. पावर फैक्टर कौन होला फील्ड रिडक्शन द लार्ज करंट जनरेट्स एन ऑपोजिंग mmf that heavily weakens the backward rotating field. ए concept माने तुम कौन हबो backward टा तबे गोटे एटा भी न कहि कि तो डायरेक्ट हम एठू बुझे स्टार्ट करिया से ए फिगर बुझे चेष्टा कले दैट इज बेटर एटा कल दिस इज इजी टू अंडरस्टैंड ए concept पर नेक्स्ट ए टू स्टार्ट करियो. Okay, so both the components A to start karo. Okay, now there are two fields which is equivalent to the sinusoidal voltage that you are applying. You are applying a sinusoidal voltage, sinusoidally varying current is flowing, sinusoidally varying flux is produced. This is equivalent to two field rotating in the opposite direction, one forward direction, one backward direction, and the magnitude of both will be half of this phi maximum. Okay. Next both the components are rotating and hence gets cut by the rotor conductor, and due to the cutting of the flux EMF gets induced in the rotor which circulates the rotor current, similar to our induction motor. It was data field asila. Okay, so the rotor current produces the rotor flux. This flux interacts with the forward component of flux to produce a torque in the one particular direction, say anti-clockwise direction. गोटे जदि एंटी क्लॉकवाइज कला माने आरटा क्लॉकवाइज डायरेक्शन रे प्रोड्यूस करिवो. ओके, सो इफ द एंटी क्लॉकवाइज टॉर्क इज पॉजिटिव देन क्लॉकवाइज टॉर्क इज नेगेटिव, बट एट स्टार्टिंग these two torques are equal in magnitude but opposite in the direction. So each torque tries to rotate in the rotor in its own direction. माने गोटे एंटी क्लॉकवाइज डायरेक्शन रोटेट करिवो चेष्टा करिवो आ गोटे क्लॉकवाइज डायरेक्शन रे चेष्टा करिवो. माने बिगिनिंग रे एम स्टार्ट करो. ओके, मो स्लाइड ता जतर नबो यू स्टार्ट विथ दिस फिगर. मत जा लगे एटा टिके एक्सप्लेनेशन ता इजी अछि. ओके, and because the net torque is zero, so the rotor is net torque is zero, so it is not self starting. Okay, dita torque आसु. तापर torque speed characteristics एटू तमे एक्सप्लेन करियो छ. The torque for the backward एटा तमे इंडक्शन मोटर रे पढथिले ए पार्ट ब्लैक पार्ट ना. So here the forward slip and backward slip रे value टा वर्तमान it is 0 to ns for the forward and 0 to minus ns for the backward पे opposite direction रे नेले. So the torque speed characteristics will be like this one. So this is the forward and this is the backward. So at this condition, okay, speed is 0 means slip is equal to 1. So a condition kono there is some forward torque and there is some backward torque, but the net torque is 0. Resultant torque is 0. That's why it is not self-starting. It जदि आप किछ देबा when the rotor is given an initial push. Next तापर concept आसियो. First concept आसिला why the starting torque is not present. Next, if the rotor is given an initial push, it creates the imbalance in the forward and backward torque. No, at the beginning kono they both are equal and opposite. Initial push dele mane se direction torque ta tiki bodila. So the torque in the direction of initial rotation increases, while the opposite direction the torque will decrease. Na eta jodi ame a direction ne boliya a torque ta increase karibo, a torque ta decrease karibo. Okay. So as the speed increases in the direction of push, the forward torque exceeds the backward torque and the motor accelerates up to its normal operating speed, which is slightly below. Eta operating region ta eta na amaro. So ए भितर कोटे आसी depending on the load it will settle at this point. So if any direction रे हम जदि initial push दबा बने, in that direction the torque will continue to increase and in the other direction the torque will continue to decrease and finally it will settle at a operating point depending on the load on the motors. This is not possible manually. No, every time you cannot give a manual push. So you should make it automatic. Now, physically now, instead of single phase supply, a two phase supply is given to the motors. So when you give that two phase supply, the next figure it should be 90 degree apart. I am just derive करथले three phase supply. So तीनटा phase current आस्तेला no phi 1, phi 2, phi 3 and particular instant the resultant हम बाहर करथले no at instant 0 हम जान नहीं थले जे दुईटा जीरो थी आ गोटे गोटे जीरो थी आ दुईटा किसी वैल्यू थी रिजल्टेंट बाहर कले and in the same manner you can find out here say okay now suppose the two phase supply and the condition is that the two phases should be 90 degree apart. So if a two phase supply is there mane eta gote phase supply and second phase is like this one close to 90 degree even not exact 90 degree only close to 90 degree suppose achi. So what will be the resultant at this instant and at this instant in bahar kariya. So the data current bartan the current IA leads the current IB by angle 90 degree, hence the rotor behaves like a two phase motor and the resultant flux has the same magnitude but rotates in anti-clockwise direction. Our derivation ta bi korichi bode eta na kor roi h okay a derivation aseni kintu you can find out in the same manner se jam data flux na जिम थ्री फेज रे हम जिम डेरिवेशन करथिले डेरिवेशन आसे नै किंतु खाली बोल रखियो ना टू फेज सप्लाई will produce a rotating magnetic field but the condition is the angle between the two phases should be close to 90 degree. Okay, so in that case a rotating magnetic field will be produced. So once a rotating magnetic field is produced then the same in the same principle it will continue to run. जो induction motor जिन हम run होतला सेटा रन नहीं जीव बाबा. ओके तापर इक्विवेलेंट सर्किट कौन हम तुम खाली इक्विवेलेंट स्टैट्यूट एंड द थ्री टाइप्स एतिका तुम सिलेबस रे अछि. इक्विवेलेंट सर्किट स्टार्ट गेम करिया what do you know by equivalent circuit? Equivalent circuit means that circuit which satisfies a certain set of equation. No, for any equation you can draw the equivalent circuit. Suppose our equation is B is equal to I. For this equation we can draw equivalent circuit. There is B like this one and R is there. This is I. So this is the equivalent circuit for the given equation. And the behavior of this induction motor. No. Three phase induction motor, single phase induction motor is similar to a three phase induction motor. And three phase induction motor equivalent circuit that is similar to the transformer with a short circuited secondary na so transformer kon thela equivalent circuit transformer equivalent circuit eta first start karo you ignore the shunt branch. So transformer equivalent circuit is V is the applied voltage and the primary resistance and reactance R1 and X1 and secondary resistance and reactance reflected to the primary X2 dash and R2 dash and the induced EMF is E1 and magnetizing branch XM. Okay. So here now that the primary thila this is the starter winding, that the secondary thila this is the rotor winding. Etu am start kara this is the equivalent only main winding is present and the starter is stationary. Rotor is stationary. The rotor quantities are now X2 dash and R2 dash. It out ke good concept clear karo. The rotor equivalent circuit. Induction motor और rotor clear किया. Rotor equation कौन है? Rotor induced EMF. P2 is equal to induced EMF is equal to or I2. Current is induced EMF by rotor impedance. No, R2 plus J X2. So this is at standstill. Rotor circuit, rotor induced EMF, rotor current का बर्तन कौन था? So whatever is the EMF by impedance. आप यदि नवा आपने इस नवा ना यदि D जुड़ा है E2, this is R2, this is X2. So, R2, X2. The current is I2. And EMF is induced in the rotor circuit. Why it is induced? Because of Faraday's law of electromagnetic induction. Because the flux linking the conductor changes, EMF is induced in the conductor. At starting, the change in flux linking the conductor, change in flux linking the conductor is maximum. No, because the rotor is at stationary condition. Flux is rotating at synchronous speed. So the relative motion is maximum, the induced EMF will be maximum. The running condition is what? So quantity change. Whether you will get the same induced EMF or different. No, sir. Yes, no, it will reduce by that. So E2 will change to on I2 S. So this is SE2 by R2 plus S8. It will be S X2. Are equivalent circuit for same one. This is SE2 and this is I2. This is R2. This is S. This is only rotor circuit. And rotor quantity can be transferred to the stator quantity. In one circuit we can represent. This is the transformer. All the secondary quantities are reflected to the primary. When you represent the vectors, their frequency should be same. It is called frequency same. SE2 to frequency and E2 to frequency, or E1 and V1 frequency. Our voltage V1 is the applied voltage. Primary induced EMF is known as E1. Secondary induced EMF E2. Secondary terminal voltage transformer. So you are transferring this quantity to the primary. Secondary voltage EMF transferred to the primary. So when you transfer this one in one circuit, you represent all the quantities. And you have to go both should have the same frequency. Transformer is problem. Secondary frequency, primary frequency same rules. In case of induction motor, even three-phase induction motor, it is applicable. So rotor frequency is not the supply frequency. No, rotor is having less frequency. So the S multiply कर देजो. Starting रे खाली same. During running रे same नहीं. So when the equivalent circuit when you represent, it called by that these two are not same because you are multiplying by S. आपको हम change करिए भाई. कौन करिए? We will divide by S. Okay. आपको यदि it divide by S, this is divided by S. So this will be E2 by R2 by S plus J. Now this EMF has supply frequency charge and S of multiplied by. What was the other one equivalent area? This is E2 and R2 will be now R2 by S. And this is simple S. Now this is having the same supply frequency. Here supply frequency nothing. So the value is the same supply frequency. So now this is correct. So in one diagram now you can represent two voltages. They have the same frequency. Then in one diagram you can represent that one. So what now you transfer? When you transfer this one R2 dash X2 dash. So this is the it is stand still the difference nahi. In running case there difference ta asibo. So एक case when the rotor is stationary and only the main winding is present, the rotor behaves as a single phase transformer while its secondary is short circuited, and these quantities resistance one so primary quantity or starter quantity, 2 is the rotor quantities, and dash referred to the others. So R2 dash means the rotor resistance referred to the stator, X2 dash is leakage reactance referred to the stator. Vm is the applied voltage. किंतु हमें जो डबल फील्ड रिवॉल्विंग थ्योरी हिसाब देखिए अपने as if there are two fields. So in this case, the equivalent circuit based on the double field revolving theory is modeled as a starter in series with two parallel rotors, as if one rotor is rotating in forward direction and the other rotor is rotating in the backward direction. So same circuit abo boton r value half कर दो, x value half कर दो. Okay. ये कैसे करो? So all the magnetizing reactance is half. Okay. One due to forward rotating rotor, as if imaginary imagine करते there are two rotors, both are rotating in the opposite directions. Okay. So the first figure, the first part is the same. Previous jathila. This is at standstill. No, it jathila same. Up to this it is same. Now this is out similar out branch. Each value is half. So xm by 2, r2 dash by 2. So this is again by 2 by 2. Should s naturally say s by 2. So xm m by 2 is the magnetizing reactance divided into two separate to represent the forward and backward field. R2 dash is the rotor resistance divided by 2. So by 2 so correct. It stands still to by s for the the running condition re asla mane to by s asibo. No, because at standstill the value of s is equal to 1. So when you divide by 1 also it will be the same thing. This quantity and this quantity will be the same thing. So running condition re mane by s button R2 by s. It will by s. In the backward field re, so backward slip को divide करिए. No, this is 2 by s. That is omega. 2 minus s. Now the data field slip बाहर करते हैं. Forward slip यदि s आला, the backward slip will be 2 minus s. So 2 minus s रे हम divide करिए. For forward, this is R2 divided by s. By 2 compare करते then data पाई. It is R2 by 2 and that slip backward slip. So 2 minus s. ये ये मतलब है. आता simplified माने इटा xm टाको तो बाहर करेगी खाली इटा नहीं. इटा उधर किसी इटा किसी difficult नहीं है. अब this is the last तमरो. Last होची some methods of starting. So up to now हम कौन देख लेते? A single phase induction motor is not self starting, but a two phase induction motor is a two phase supply can produce a rotating magnetic field. कौन पे self starting नहीं? Because the rotating magnetic field is not produced, and rotating magnetic field can be produced by a two phase supply, but condition is the two phases should be close to 90 degree apart. That initial jam कौन करें? We will use one more winding so that we will get the two phase current. So how to create the phase difference of 90 degree? One by is the capacitor starts. So in this case the main binding and there is an auxiliary binding and the capacitor is connected here. So the capacitor is connected so that the current through this one and current through this one will be 90 degree apart, close to 90 degree apart. So this is known as a capacitor start induction motor. There are different types. Either you can choose the capacitor to remain permanently or during starting only it will remain. So accordingly the classification is capacitor start. So only starting rate I use. Running rate बाहर करिया पे that is a centrifugal switch. So when the rotor attains a particular speed 70%, it will remove this circuit out of the circuit. कहीं हमने analysis देखते ले जाए. If the rotor is given an initial push, then a net torque will be developed and it will rotate. It will continue to rotate in that direction. So initial पे हमें इटा use करते हैं centrifugal switch. So a capacitor start induction motor is a single phase AC motor that uses a starting capacitor in series with auxiliary winding. Close to that one, exact 70. इस समय पर है बाहर automatic से it will design that a particular speed रे centrifugal force जहाँ हो सकता बाहर कर दो switch को 70 रे करिया बोल बाध्य है. तो initially 0 हो तब और starting capacitor किस काम है? 0 plus है गला बढ़ला. If it starts rotating, then also you can remove. Okay. तो particular time पर है ना remove कर दियो अंतियो. The centrifugal switch ला केतोल act करियो that during design you can ensure केते स्पीड रे सेटा बाहर है तार रेकॉर्ड स्पीड जति अछि एतिक अछि तो ए स्पीड रे सेटा बाहर पड़िबो. So what is the function of capacitor? The capacitor causes the current in the starting winding to lead the main winding current. So that means as if two-phase current it will produce. So thus creating a rotating magnetic field which is necessary for the starting. So the function of capacitor is this one. And centrifugal switch, if you don't want the capacitor to permanently remain in the circuit, you can remove that using a centrifugal switch. The characteristics, the two currents, okay, the main winding current and the capacitor current. So capacitor current will lead the voltage by some angle, and because the main winding is inductive, so it will lag the current. So the angle between the two currents, IA and IM. IA means auxiliary winding current. This is the main winding current. This is close to 90 degree. So the torque speed characteristics will be now like this one. So main plus auxiliary winding is like this one, and when the capacitor is removed, then only the main winding characteristics. So it is similar to our induction motor characteristics. Induction motor torque slip characteristics जे भी थला से बड़ा थला. खाली difference होचे एटा मतलब 0 रो स्टार्ट होचे induction motor टा के ऊपर स्टार्ट होता. कहीं induction motor रो starting torque थला और starting torque 9. So the only main winding is there means it will look like this one. At starting, this is the point of starting. At starting, the torque is 0. So 0 to start over. Then the shape is similar to our torque with the induction motor जे में थला same. किंतु जब आप capacitor दो जो बने, it will start like this one. So at 0 speed or starting, there will be some initial torque which will be like this one. So it is जब switch off कर capacitor बाहर आता है. So here the operating point. Okay. So here the starting torque is high. And the capacitor need only be short time rated. अल्प समय में that is put into use. So the rating the short time. So the motor offers high starting torque, around 50 to 120% higher than the full load torque. And due to the high starting torque, for those applications, against heavy load जब आप start करिएगा, you can use this motor like compressors, refrigerators, conveyors, pumps, machines. So this is capacitor start, only starting. How does the capacitor run permanently? Permanent roibo माने एक characteristic starts. Both auxiliary and main winding. So similar capacitor नले हबनी. एटा कौन होची? Only difference is this is short time rated. It long time rated है वो पड़ियो. So that is the difference. Capacitor run that's one. So here there is no centrifugal switch. So capacitor run induction motor is a single phase AC motor that keeps running capacitor permanently connected in series. So it is a centrifugal switch doctor. So this design eliminates the need for a centrifugal switch, and so permanently capacitor oil power factor will be improved. Yes. A short time route अलग आता है, long time route अलग आता है. Short time rated तार सब हाँ किसी को फिगर अच्छे मूवी देखो तो ले माइक्रो फैराड के माइक्रो फैराड तापर ये जो मशीन तो करंट ऊपर भी डिपेंड करे 1.5 भी का भाई मशीन तो साइज ऊपर भी डिपेंड करियो ना. हाँ सीलिंग फैन माने और कैपेसिटी कहते हैं. That depends on the machine. Generally, say range like 1.5, 1.2. The capacitor permanent roile. One advantage is, advantage कौन आइटे बतन capacitor run का जुटा में नोचे. Capacitor will be permanently there. So overall power factor will be better here because capacitor is there. Okay. जार कैपेसिटर कंटिन्यूस रेटिंग थी वो इटे सेतवे टॉर्क स्पीड कैरेक्टरिस्टिक्स इज डिफरेंट से तावलिया नहीं केवल एटा खाली शिफ्ट हैला बत. तो एलियर यदि कैपेसिटर इज देयर मींस द टॉर्क स्पीड लाइक सिमिलर टू इंडक्शन मोटर को टॉर्क स्पीड कैरेक्टरिस्टिक्स आर पाउच परमानेंट कैपेसिटर मोटर. So capacitor run induction motor, these are ideal for high load applications. permanently static torque by କିନ୍ତୁ ତାଠୁ ତାର starting ଟା ଆହୁରି ଅଧିକ ବାକି କାହିଁ ତା rating ଟା short term rating our starting torque is still higher compared to this one এটা in between ଗୋଟେ କହିବ ଏଇଭଳିଆ what is it direction টা हाँ 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 it will rotate in the opposite direction हाँ बस बस कैपेसिटर बने हाँ हाँ स्टूडेंट पचार सब आइडिया का आसला जाने बस देखी बाहर करके बही बही देखी बाहर करा पड़ो नहीं तार एसी रे गोटे कौन आसू एसी रे कौन जो ड्यूरिंग फर्स्ट साइकिल से कोड चार्ज नौ सेकंड को चार्ज नौ समय तुम डायरेक्शन दीटा कौन गोटे चेंज हो ना डायरेक्शन फील्ड इज रोटेटिंग नाउ इन द ऑपोजिट डायरेक्शन ना रोटेटिंग फील्ड ऑपोजिट डायरेक्शन रे प्रोड्यूस होछि तो फेज सीक्वेंस कौन गोटे चेंज होछि तार हला ए पर बी आस्तला माने फर्स्ट बी आसीबो तापर ए आसीबो इमित कोन हे चेंज होछि सेटा कोरिलेट करिगा ताको एक्सप्लेन करि हबो हला तुम से मेन देखो ऑपोजिट डायरेक्शन केतल रोटेट हबो ना रोटेटिंग फील्ड शुड बी प्रोड्यूस इन द ऑपोजिट डायरेक्शन फर्स्ट फेज ए टा लीड करथला फेज बी माने बर्तन बी टा लीड करछि ए उदाहरण तार ऑपोजिट टा होछि 90 डिग्री क्रिएट होछि किंतु ऑपोजिट सेटा कोन भाई होछि सेटा एस्टैब्लिश करियो पड़ो कैपेसिटर जदी चेंज हला हां हां हला ऑपोजिट बेले सेटा एतर ब्लेड आको सेम डिजाइन हेछि जे सेटा पे सेटा डिजाइन पे सेटा हवाटा ऊपर पड़ो व्हिच इज नॉट डिजाइन टू इंटरचेंज दिस वन नेक्स्ट से जो फेज डिफरेंस कैपेसिटर करंट जो डायरेक्शन देला ऑपोजिट डायरेक्शन गला वाला कोड जाउछ जोटा कि जो करंट नहीं थी तार ऑपोजिट डायरेक्शन करंट जाई कि सेटा चेंज होछि माने मे बी मो ता भीतर स्टडी कला कहि परि एग्जैक्ट आंसर ता हला एटा डायरेक्शन ता कोन चेंज होछि कैपेसिटर करंट डायरेक्शन ता को ऑपोजिट डायरेक्शन में कोन जाउछ ऑपोजिट डायरेक्शन एटा लीड कला पर तो एटा लीड कला होते एटा जति लीड कला पर ता whatever field is that is in the opposite direction रे फ्लो होतबो हला मु देखि कहबी मु हला ना एबले पिलान पचार लेगा हम जानी हम नॉलेज बढ़ियो नले हम नॉलेज भी बढ़िबोनी ना कोइ रे जा अछि हम से कहि चलते कोन हला होला एटा लास्ट वन ना एटा दिला एटा उठाओ मेथड ऑफ स्टैटिक में this is the capacitor run hala so
what is shredded
pole तमरा नाही सिलेबस रे shredded pole repulsion ए सब किछ नाही हला तो सब किंतु हमर सिलेबस रिपोर्ट रे अछि बुल्ला रे अछि एट ना कि मते जा सिलेबस दिल त नाही किछ हेते जल्दी सरजियो कोन एटा कोन एटा जनरली कोन हमर मोर एक्सपीरियंस कोथि एटा पूरा एंड सेक्शन रे अछि नो आई दुईटा क्लास कला पिला मूड न तो जेनराली मुझे भी पूरा पढ़ाएनि अल्प पढ़े थी सर आप नोट्स दे दिंतु आम अन्य आगे पढ़ीदेव हो रखिदे लास्ट प्राय हुए हाँ लास्ट आगे आसबेनि खाली नोट्स टा मागिक नहीं करके आम एक्सट्रा अच्छी शेडेड पोल रिपल्सन इनका कौन अच्छी तार नोट्स टा देखिए रखिए क्लास पूरा बंद करदे लास्ट So one is permanent connection, which will improve the efficiency. Okay, and capacitor run rate, smaller capacity, continuous time rated in kono oil filled capacitor, characteristics. How would अच्छी इटा? ये दीटा capacitor use करती. During starting क्या ये दीटा एक दिप का इटा. आर कोनो high starting torque. Short time rated माने you can get high starting torque, and continuous माने तमरे पावर फैक्टर इंप्रूवमेंट हबो तले दीटा अगर एडवांटेज पाया पे हमें देयर विल बी टू कैपेसिटर्स वन इज यूज्ड एट स्टार्टिंग एंड वन इज यूज्ड एज रनिंग सो इट विल हैव बोथ हाई स्टार्टिंग टॉर्क एंड पावर फैक्टर इंप्रूवमेंट दैट मींस द थर्ड वन सो ऑन द स्टार्टिंग माने यूजिंग सेंट्रीफ्यूगल स्विच यू कैन रिमूव दिस वन एंड रनिंग कंडीशन रे one more capacitor will be permanently connected. So while the capacitor start motor disconnects the capacitor start capacitor run or two value capacitor motor. So smaller value continuous duty capacitor to remain in the circuit, which improves the power factor, and a large capacitor for high starting torque. So three टाकर benefit पाया भाई इटा करो आर characteristics बने ए बढ़िया. So high starting torque आसीबो और switching कला परे it will be like this one. So इसका यूज करिए हाई माने 8 to start आवा कथा torque का उठी हाई बोल इटा का लास्ट सेंट्रीफ्यूगल स्विच माने सेटा स्पीड डिपेंडेंट जते स्पीड गोटे पर्टिकुलर रेंज को आसिले से स्विच विल बी ओपन. सेंट्रीफ्यूगल स्विच ना फोर्स ता जब हम एटा धरि रोटेट कर बाडी दे सुतारे गोटे वेट धरि के रोटेट जे बेसिक स्पीड रोटेशन करे तार फोर्स ता बॉडी गोटे पर्टिकुलर फोर्स आसिले स्विच ता ऑपरेट हो ओपन हे इवन हम स्पीड गवर्निंग के थाए अप्लाई वाला अरेंजमेंट थाए से होया. हम स्पीड जदी अधिक स्पीड रोटेशन कलो तार से फोर्स अधिक बढी बोल था ऊपर if speed increases the force on that component will increase. So at a particular force that switch will operate. So open कर ठीक अछि ए नोट्स आपका एटी अछि प्रीवियस आगा मु गले पठेबी सब
सर हमरा शुरू
एटी असले एटी कांटेक्ट करिवो किंतु खाली नोट्स रे काम दबनी तम प्रॉब्लम किछि आइ नै आ प्रॉब्लम भी करियो पड़ियो आ केतरा डीप कांसेप्ट बने अन्य एटा फॉर स्टार्टिंग पर्पस एटा कोन कर यूज कर पारी इन एडिशन टू दिस इज अ सप्लीमेंट्स आ काई डिटेल एक्सप्लेन हे नै मोर शॉर्ट कट रे पॉइंट वाइज इन लिखाई तो डिटेल में तुमको भला बुक भी देखियो
टाइम नहीं ना सर ओनली 2 मंथ
आई ओनली 2
मंथ सर
क्या सर नहीं क्या बजाय मु पढो छी हम कोडा चला सिंक्रोनस मोटर का स्टार्ट करू पहले ऑपरेशन करला
माने सिंक्रोनस मोटर
मशीन पूरा मु पढो छी हां मशीन स्टोर सिंक्रोनस जनरेटर सरला और मॉडल 1 2 सरला साइलेंट पोल नॉन साइलेंट पोल सरला पहले ऑपरेशन सरला ओपन सिंक्रोनस मोटर का स्टार्ट जो ये असुविधा सिंक्रोनस मोटर तापर इंडक्शन मोटर तापर अछि सेकंड एटा मु जे पढो जे से कहबा कोगो आपण आसिया को न लाग पीपीटी करियो बहुत टाइम लागे बने पड़ियो बारंबार पड़ियो हेई कोटरा बोल दो पीपीटी अछि सर जल्दी सरी गेला
सर
अब कौन फोटो से
सर लाइट पे चला
এই লাইট এই উপর লাইটটা দিলে
लाइट पे आसे
हां पवित्र जैसे पेज दे थे सब माने भलो परफॉर्मेंस पे डिपेंड हो हां एटा आउट तो ब्रेक टाइम एटा करता ठीक भलो साथ प्रॉब्लम के साथ डिस्कस करता कि टिपिकल क्वेश्चन के तरह गेट फॉर क्वेश्चन करता एटा तो मतलब जो आपको भी कोर्स टू कम वो इंटरेस्ट कम आती है ऐसा मोशन इतना है हम लोग सब स्टार्टिंग 11 महीना थी वो आती है जब वो था ना मोड समथिंग प्रपोजल दे वेरी ब्रेक टाइम में
इसको स्टार्ट हो गए टेक्नीशियन
स्टार्ट कौन शुरू कर ले ଭଲ ସବୁ ପୁରା ଫ୍ରେଶ ନେଇକି ଯାଇଥିବ ଯାଇକି ପଢେଇବାକୁ ସୁବିଧା ତାପରେ ବି କରିବେ ଯଦି ଜଣ ଲେକ୍ଚର ଚାଲିଛି ତାର
Sir, I'm done. You are the main person of this thing. last for